All right, so as a quick application of dot product, we will discuss when two vectors are perpendicular, and then we will define orthogonal complement. So let me start with some quick example. So pick a pair of two vectors which are perpendicular. So we have vector A and then vector B. Like this. And you want to calculate dot product two vectors, A dot B. Then, well, we need the magnitude. And then cosine theta. But the angle is 90. And no matter what those magnitude, cosine 90 is always 0. So this dot product is always 0. So this is quite interesting. Whenever you pick pair of two vectors which are perpendicular, then the result is always 0. Actually, that observation gives us some criterion to tell when two vectors are perpendicular. So simply, whenever you have 0 dot product, then we say two vectors are perpendicular. And notation is like this. Okay, so we read this A perp B. Whenever you see this symbol, you can say two vectors are perpendicular. On the other hand, we can also characterize when two vectors are parallel. So one vector is like this, and the other vector has the same direction, like that. So in this case, well, two vectors share the same direction. So in this case, you can stretch or shrink one vector to get the same magnitude. So if you, for example, if you take A and stretch a little bit, then you will get the same magnitude. Then you will get the same vector, of course. So B is scalar multiple of vector A. And then here, C is subscalar. Then you can say two vectors are parallel. All right, so we are ready to define orthogonal complement of some vector. So before defining orthogonal complement, let us use this example, vector A, 1, 2, and then we will define the orthogonal complement. So let me draw this vector 1, 2. So vector has coordinate 1 and 2. So vector A looks like this. Okay, for the orthogonal complement, what we want to do is to rotate this vector by 90 degrees counterclockwise. So what we want is rotate A by 90 degrees counterclockwise. Then you will get a vector like this. And once you figure out this coordinate, then you can see the relationship between two. Well, if you look at this vector carefully, you can tell this coordinate is -2, and this is 1. That's it. So we have vector -2, 1. Okay. So this is the result after we rotate this vector by 90 degrees counterclockwise. So if you compare this coordinate and this coordinate, you see this coordinate is not random numbers. So first coordinate 1 here is in the y coordinate, and this comes from the y coordinate, but you need to change the sign. That's it. So orthogonal complement of vector a comma b is going to be, well, you swap the coordinate b comma a, but you need to change the sign for this b. That is orthogonal complement. Notation is this. So you put this symbol on the shoulder of the vector, and so this is the orthogonal complement. So geometrically, orthogonal complement is the vector that you will get after rotating the given vector by 90 degrees counterclockwise.